right, so 7-1 is the last chapter before your final exam. And I happen to be missing one of my pens. There we go. It pulls in some prior knowledge from algebra. Are you ready?
Sorry, I cracked my leg.
Well, it's not usually a funny thing. So it pulls in prior knowledge from both algebra and geometry. So you should find this a little bit easier than the last chapter. So 7-1 is really using proportions. So you're going to see some word problems within this because we're going to take our skills and apply them to word problem situations. I'm losing my voice, so I apologize. All right, so how many of you remember what a proportion is? Really? Okay, I'll bet you when I put it up here, you're going to remember. Didn't we just use one in your Ames review sheet last week?
It's a fraction.
Okay, it's a fraction equaling a fraction, right? Remember we had that cube where we cut a rectangular block from that cube, and then we compared the weight of the cube to the weight of the block and the volume of the cube to the volume of the block? That was a use of proportions. And so we can use proportions to solve a variety of problems. So first thing you need to know is that a proportion contains ratios. So all a ratio is a comparison of two quantities. Bless you. If I mention it's a ratio, it's a comparison of two quantities with the same unit of measure. So I would be comparing teachers to teachers, people to people, miles to miles, seconds to seconds. And ratios can come in three different forms. They can either look like a fraction, A over B, or A with the word 2, B, or what's the last one? A colon B. So those are the three forms that they come in. Generally in math we like to use this form because it's easier in calculations, right? All right, so then you have your proportion. A proportion is just two equal ratios. And technically we can use rates in a proportion as well. And we did that last week when we compared pounds to cubic inches. So those would be two different units of measure. However, having said that, you can set up your proportion four different ways. So you could set it up in that situation with weight being compared to cubic inches. You could set it up so you had the same unit of measure over the same unit of measure. So you could do weight over weight equals cubic inches over cubic inches. And wouldn't those be ratios and wouldn't the units of measure cancel out? So you can do that. It just doesn't matter. And then your ratio is going to look like this, or your proportion is going to look like this. A over B equals C over D. And it is red, and if you see this written in words, then you know that they're giving you a proportion. It would be read A is to B, so A is to B. The equal sign is read as C is to D. A is to B, as C is to D. All right, so I'm going to start off with a problem that is a little wordy. And they'll do that to you on purpose to try to confuse you. So here's example 1. Students in a geometry class measured the distance from the base of their wrists to the top of their middle fingers. And found the average length to be about 15.9 centimeters. We're not done yet. We'll let you catch up. They also measured their heights and found an average of about 167 centimeters. Still not done. We're almost there. Cue. Daniela. So the question is, what is a good estimate for the ratio of height to length of hand? Now, your textbook assumes that you are using a calculator at all times. We don't let you because of the Ames test, right? So I'm going to let you use your own discretion, and you decide when a calculator would be beneficial. So obviously, if it's something you could divide or it should be a fraction answer, you're not going to use your calculator. But in this case, you would. They're telling you what ratio to use. They're saying for the ratio, and what follows the ratio? Height to length of hand. Aren't they telling you what goes in the numerator and what goes in the denominator of that ratio? Right? And so I'm going to have my ratio as height over length of hand. Now they could have said the ratio of length of hand to height. You have to pay attention to what they're telling you to put where, because ratios can be written two different ways, depending on your opinion and how you want to write it. So because they stated that, we're going to take our height, which is 167 centimeters, and we're going to put it over the length of hand, average length of hand, which is 15.9 centimeters. Is that something that you really want to divide out? No. Could you? Yes. When you take your test over this, I'm going to give problems where you don't have to have a calculator. So you're only using it because I'm not going to rewrite your textbook. So we're going to take 167 and divide it by 15.9. If I asked you to round to 2 decimal places, what would you write? 10.50, because I asked for two decimal places, right? What follows the 0? A 3. Because it's less than 5, we keep the 0 at a 0. And so I'm going to use squiggly equal signs. Why? I'm rounding, right? It's not the exact answer. So we've got 10.50, but because it's a ratio, I'm going to leave it over 1. If they ask you to write the ratio, that's the only time you're going to write a fraction that would have a denominator of 1. You're not always going to have 1 in the denominator of your problems. It depends on how they're asking it. So the ratio of height to length of hand is 10.5 to 1. So maybe for every every centimeter on your hand, you would have 10.5 centimeters of height. That's what that's saying. Okay? All right, so can I flip that? Then the next one is more of a problem straight from algebra. But we're going to review this so that when we use these with our other problems, you remember how to do them. So example 2, you are to solve. You've got x plus 3 is to 8 as, your equal sign, 4 is to 3. How do you solve proportions? Okay, so with here we're going to use cross products, right? If I could have multiplied 3 by something to get 8, then I certainly could have multiplied 4 by that same thing and this by that same thing. But we don't have that situation here. So you do have to use cross products. So we're going to multiply those together and those together. So for your note purposes, I don't expect this in your homework, but for your notes I would expect to see 3 parentheses x plus 3 equals 8 times 4. Then you go ahead and solve that. Bless you. So here's a situation where you should not be using your calculator. If you subtract 9 from both sides, you do get 23, right? Bless you. Oh, bless you. I don't know why I'm blessing him when he's coughing. And then divide both sides by 3. 3 doesn't go into 23. You're still going to leave it as a fraction. So I don't want to see a decimal answer because that's telling you you're using your calculator. Only use it to help you through the rough spots. All right, next problem is a true word problem. So example 3. And this one is not geometric in nature, but we'll get to 1. So this one says if 1 US dollar is worth 102.70 Spanish pesetas, and a shirt costs $19.75. Oops, make that 95 cents in US currency. How much would it cost in Spanish pesetas? So because it's a word problem, it's a 4-step plan. So we have a straight conversion. Straight conversion. They said that, and we can put in here if 1 US dollar is worth 102.7 Spanish pesetas. That's no different than saying that 12 inches equals a foot or 60 seconds equals a minute. Aren't these two equal quantities? 1 US dollar is exactly equal to 102.7 Spanish pesetas. I can write that as a ratio, actually technically a rate. $1 over 102.7 Spanish pesetas or 102.7 Spanish pesetas over $1. Just like I could write 12 inches over 1 foot or 1 foot over 12 inches. It's a conversion. There's a different way to solve this problem than a proportion, but you're going to use a proportion today. So what is it that we don't know? Okay, we don't know the cost in Spanish pesetas. So I'm going to let X equal the cost of the shirt in Spanish pesetas. So for your equation to solve, you're going to set up a proportion, and you have to decide what your ratio wants to be. I'm going to put my ratio as dollars over Spanish pesetas. You could choose to do Spanish pesetas over dollars. It doesn't matter. But you have to maintain that consistency in your rates and ratios. So for our purposes, we're going to use this. Your left side should always be your full ratio that you've been given. You should know this full ratio, at least for one side of your proportion. So I'm going to put 1 over 102.70 equals. You can put the units of measure in there if you want to. It doesn't matter. It might confuse you. Because our answer is going to come out to be in Spanish pesetas. Then over here, I know that my shirt costs $19.95 in U.S. currency. I'm trying to find Spanish pesetas. What goes in the numerator? Because dollars is in the numerator, $19.95 goes in the numerator. So what are you going to put in the denominator? X. That's your unknown, that's your Spanish pesetas. Now, solve it, right? Don't we use cross products? Cross multiply and solve. Wouldn't a calculator be handy here? Yeah, and there's really not a whole lot of work to show other than that. So we've got 1 times X is X, and then 102.7 times 1995 I will help you out with. That is 2,048.87 pesetas. So you write your therefore statement. Answer the question, a complete sentence. Therefore, the shirt would cost $2,048.87 Spanish pesetas. Alright, so none of this has been related to geometry yet, right? So let's go ahead and relate this to geometry. Can I flip it? No complaints? Okay. So for the last problem, example 4, the ratio of the measures don't start that again, of 2 consecutive angles everybody better be writing. David, put that away. You're not studying for your test right now. You're learning a new lesson. You've already missed a whole sentence.
I wasn't.
Yeah, I know you're not writing anything. Do you have all that written down? So the ratio of the measures of 2 consecutive angles between the parallel sides of a trapezoid is 5 to 7. Period. The ratio of the other two consecutive angles I'll make that singular. 2 consecutive angle measures between the parallel sides is 1 to 3. Period. Find the measures of the angles in the trapezoid. purposely, the picture is left out. Because you're supposed to know what a trapezoid looks like. You're supposed to know what consecutive angles between parallel sides is referring to. And they're real specific in this. You're like, why do they write so much? Because there's 4 sets of consecutive angles. Not all 4 sets of consecutive angles in that trapezoid are what they're talking about. They're only talking about 2 of the sets. So here's your 4-step plan. We don't know what kind of trapezoid this is. We don't know if it's an isosceles trapezoid or a regular trapezoid. So you cannot assume it's an isosceles trapezoid without them telling you that. So you can only assume that it's a regular trapezoid. So I would just draw any old regular trapezoid. Doesn't have to be isosceles. Could be, but doesn't have to be. And I'm purposely drawing something that is not an isosceles trapezoid. But you could. So the first ratio that they give you of the measures of 2 consecutive angles between the parallel sides. So here's my parallel sides. So this right here and this right here would represent 2 consecutive angles between the parallel sides of that trapezoid. And they're saying that that ratio is 5 to 7. What do you know about these angles on a trapezoid? They're supplementary. So that's one thing that you need to make that own connection on by yourself. So I know that they're supplementary, they should add up to 180. So if I put a 5 here and a 7 here, and it doesn't matter if you get them mixed up because this one's the obtuse and this one's the acute, so technically shouldn't that probably be the 7 and that be the 5? But it really doesn't matter. Don't stress yourself over the minor details. What's 5 plus 7? 12. Is that 180? No. So then you could guess and check your way to it, but you have to always stay in this ratio of 5 to 7. So I have to go in multiples of 5 for this one all the time, and I have to go in multiples of 7. So my next choice would be 5 plus 5, which is 10, 7 plus 7, which is 14. 10 and 14, is that 180?
No.
No. Then my next multiple of 5 would be 15. My next multiple of 7 would be 21. Do I want to keep doing this until I get the right answer? No, I could, but I don't want to. So, but what I do know is that if it finally turns out to be, I don't know, 5 multiples of 5, I know that this would be 5 multiples of 7, correct? So whatever they turn out to be, angle-wise, they're both going to be multiplied by the same number to get there. Do I know what that number is? Do I? No. So that's what I'm going to let my x be. I'm going to let x represent the multiple that the number or the multiple that I'm going to multiply those by, because I know they're both the same. So anytime they give you a ratio like this, tack an x onto the end of it. So if I gave you the 3 angles in a triangle, and they were in a ratio of 3 to 4 to 5, you'd put the different angles as 3x, 4x, and 5x. And you would know that those interior angles would add up to 180 degrees. No different here. So one of your equations to solve will be 5x plus 7x equals 180. So let's use the same thought process as here. Then it says the ratio of the other 2 consecutive angle measures between the parallel sides. So these are the other 2. 1, 2, 3, 1, 2, 3, 4. So these are the other 2 between the parallel sides. They're in a ratio of 1 to 3. Well, obviously 1 plus 3 is not, these should be 180 also, shouldn't they? Mm-hmm. Is it going to necessarily be the same ratio as these 2? No. It may, but it most likely isn't. So I can't use the same variable x. I have to use a different variable here, so I'm going to use y. So the second equation I have is y plus 3y equals 180 degrees. So you have 2 equations with different unknowns. You do not have a system here. You don't need a system here. Go ahead and solve those separately. you have your values yet? What'd you get for X? 15, and for Y? 45 is correct. Does that answer the question? No. What does the question ask? We have to find the measures of the angles. So then we have to go and plug this into our picture. So for this angle, I'm going to take 5 times 15, because it's X. What does that give me? What does it give me? 75 degrees. And I'm going to plug it directly into this one because I want to compare these two to make sure that they're supplementary. I'm not going to subtract that from 180 because if I made a mistake here, I'll make a mistake subtracting it from 180 to get this one. So you'll make 2 mistakes. So go ahead and take the effort and multiply the 7 to the 15 as well. What do you get? 105. Do these add up to 180 degrees? So most likely my answer is accurate, right? So then this angle, 45 degrees. We don't have to do any work there, right? But what is 3 times 45? 135 degrees. Does that add up to 45 to make 180? Yes. So now you have all the information in order to answer that question. So therefore, the measures of the angles in the trapezoid are 75 degrees, 105 degrees, 45 degrees, and 135 degrees. Done. So that doesn't seem so bad, does it?